So that last video was kind of boring, and I hate, going over like syntax and code and when I'm just printing things out. You could tell I'm not motivated when I talk that way, and it just sucked, so we just cut it short. I'm going to upload it because I have to cover that crap, but this is where I actually get to talk about like what's useful about data structures. So the hell with before. Now we're actually going to do something cool. So I pulled up the original bouncy ball. You could basically see this is where we left off with the inheritance video. I think was the last time I talked about this. And this is going to be pretty short because basically I'm going to show you how to take this borderline hack thing we have, which is basically a constant array of pointers, a low-level C array, and use a data structure instead. And I'm going to explain essentially some of the decision process that might be involved in taking something like this. I'm going to explain the processes behind maybe how I might think if I was trying to turn code like this and make it more like a normal game engine. First thing I'm going to do is include some data structures that we might use. Vector and list are two that come to mind. And I am going to first try out to see what would happen if instead of GameObject being a standard array, if it was a vector. Really? A vector of GameObject pointers instead of a static array. We don't need this max objects crap anymore, and I believe, I'm almost sure, well it doesn't matter, yeah, if it starts out as null, pointer is not because it starts out empty. So max objects goes away. So basically everywhere that I was using GameObjects now, I'm going to basically swap it out for this pointer, or this vector. So using our new syntax here, instead of having to do any of this, I'm basically just going to say for auto GameObject in GameObjects. I did not use ampersand here because it's a pointer anyway, so I did not use the reference parameter. I don't have to check anything. And basically I just say GameObject and then I use it. So that is an infinitely simple syntax already, as you can see. I'm just going to look through some more cases where I need to change that stuff out. Everywhere I add to it, I don't need num GameObjects anymore either. Where is that? That would be covered in GameObjects.size, so that's not necessary anymore either. So when I'm adding to this thing, it's as simple as me just basically saying bouncy ball star ball equals new bouncy ball, and then I say GameObjects pushback ball. None of this crap, none of this crap. Same thing here. So every time I add something, I just push it into the data structure, in this case the vector, and it grows the vector dynamically for me, which is awesome. So every time I want to add something like a plane, I just push it in there, and it's there. Same thing here. When I'm updating, I can replace all this with just a simple range-based for loop. And I basically just say GameObject update instead of GameObjects I. So there's this. Dynamic cast that I do is on this now. There's a chance I might have made like a mistake here. At the very end, we free everything out, and the way that I do that is I basically do the exact same kind of loop, except now I don't have to set anything to null, I just delete it. And this is just good practice. This doesn't matter anymore because I'm not using it, but typically once I delete everything in an array of pointers, I will clear it, which basically resets it to containing nothing, just as a matter of good practice. So if I were to run this, and I messed up, line 176. Oh, so I just made a typo here. So I'm going to go see that it works exactly the same as I would expect. However, I'm not dealing with that ugly array anymore. Alright, so now you can basically see that I have this program adapted so that I'm able to use these data structures to basically house all the game objects, the polymorphic game objects, in my quote-unquote game engine. So suppose that we were insane right now when we wanted to have it so that airplanes could come in and out and objects can be created, destroyed all throughout the lifetime of the program. Now what I had before with that stupid haphazard pointer array, that would have been kind of kludgy. And believe it or not, even with the vector, I don't know if you guys remember from my asymptotic complexity talk, but when I mentioned the data structure to use that's the most efficient for adding and removing items from an array dynamically, or from a data structure dynamically, is actually a list. It's considered very efficient to insert in the middle of and remove things from a list. So what I'm going to do is I'm going to swap this out for list. And you can see syntactically everything's the same. Now it's using a list. It's only the implications of essentially the performance of specific methods on the data structure itself. For example, how efficient it would be to add things and remove things and so forth. So what I'm going to do at this point is essentially I'm going to allow that airplane that we added in to be added dynamically and deleted dynamically from the program itself. So basically I'm going to take this code here and I'm going to cut it, and I'm going to throw it into the update method of the game, which looks like I just do right here in the middle of the loop. I don't have a process function. That actually kind of bothers me. I'm going to put one of those in like right now. So what I'd like to do at this point is dynamically add the plane in the middle of the loop and dynamically erase planes that have gone less than a certain point. So basically right now, oh, this is kind of cool actually. I know how many planes I have from above, so if I don't have any, then I'm going to add at least one. And that's going to cover the first plane. And I want the position of the plane to actually come from off the right side of the screen. So 640 will be just fine. So we have the plane coming from there. And I'd like its Y position to be sort of random. So I'm just going to, at this point, just put random 480. That's good enough. So the plane seems to be coming from a random Y position. And every time the plane goes off the edge, I'm essentially going to delete it from the simulation. So I'm iterating through all the objects here, and I basically can determine right here if I'm working with a plane. So what I can do is I can say, I hope, let me look at my plane class here. Game object. See if game object has a position. It does. So I have a set position, but I was dumb enough not to write a get position. So let me just go ahead and quickly here write a float get x, float get y. We quickly implement these for game object. So now if the plane get x less than 0, so what I'd like to do is essentially destroy the plane and completely remove it from the data structure. Now when I'm doing fast enumeration here, I sort of can't do that. It's considered illegal when you're enumerating through a data structure to remove something from the data structure while you're enumerating through it. So there's a couple options we have. One, maybe I could set the game object equal to null using a reference, and then go through and delete all the objects that are null, but that's kind of like I'd still be enumerating while I'm checking, so that doesn't really help. So commonly what I do in this case, and I'm not 100% sure if it's the most efficient thing in the world, but I always know that this data structure will always be small. It'll never grow very large because typically I'm not deleting many things. Usually what I'll do in this case is I'll actually create another list, and it'll be, yeah, list is fine. It'll be essentially the list of all things that I plan on deleting from the game objects this loop. So basically, it'll be a list of game object iterators, and it looks kind of nuts, but basically this is called toDi, and then I pass the iterator for the plane in right here. So you see we basically have a problem here because in C++ it is considered illegal to delete anything from or modify a data structure while you are enumerating through it. So essentially this is going to be one of those cases where we actually can't use this anymore, but fear not, it's not that hard to convert it to using iterators. We're just basically going to say for auto it equals game objects begin, it not equal game objects end, it plus plus, and we're golden. However, there's a caveat here as well that we have to be a little bit careful about. So I can at this point say game objects erase it. Also, hold on. That'll keep me from having to rewrite this code. Now, even though this probably will work in this case, there are some STL data structures where once you erase an iterator, you essentially invalidate that iterator, such that by following this code, by doing it++, there's a chance that this code will break because it might not be valid anymore. Getting around this is really, really annoying, so much so that I've actually paused and edited and stopped myself from talking, trying to explain a way to not confuse you, to show you like this stupid problem and how to solve it in a way that's not confusing. And you know what, like, it's just going to have to be complicated because it's a complicated thing. The way I handle this is I actually will create my own list of iterators and push into that list of iterators and call those things to be deleted or to die, and then loop later and delete those things. I find that's the safest way to handle it. Simply because if I don't do that, I have to make this for loop way more complicated, and it already is complicated. So this is basically what I'm going to do. I'm going to have a list of game object pointer iterators and call this to_die. And this is basically populated. It'll never get very large, but it'll always contain safely the number of things that need to be erased. And then instead of doing this here, which is risky, I basically add it to to_die. I add it to that, and then I iterate through this. And inside here, I safely erase the thing inside here like so. I could delete it up here, but it's not that big of a deal. The important thing is that I basically get rid of it. This is fine. The only slight issue I might have with performance sake is that I'm allocating an entire data structure and destroying it inside one call to update. But it's going to be so fast that the performance would essentially never cause a problem. So assuming this doesn't crash, you can see that I'm basically adding and removing planes. And I'm just going to, for the sake of argument, add a bunch of these and destroy a bunch of them. So for every plane, for every time I run into that I don't have any planes, I'm actually going to do this 5 times. So eventually, if I leave this run long enough, there are going to be way too many planes, and it's going to take over the entire screen, I think. Oh, actually, for every time one goes away, there won't be that many. I'd have to phase offset these to actually make that happen. So let me just go off on a tangent like I always do. Isn't that fun? Doesn't hurt anybody, I guess. All right. So that's basically a really, really, really brief example of how to put your game objects inside of a data structure. I always end up going off on tangents here. It bothers me that they disappear when they shouldn't. So let me just do like -32 here. I don't know why it bothers me, but it does. You should go completely off the screen. That looks more realistic. Okay. So that's an example of how to put your game objects in a data structure and handle the insanely complicated case of deleting them.